Okay, in the previous class we solved up to example 3. Now in this class I will solve the next examples. That is example 4. Okay, example 4. So now here I will ask one question. Velocity is a scalar quantity or vector quantity? Velocity is scalar quantity or vector quantity? Comment your answer first. Velocity is scalar or vector quantity? First, this velocity is scalar. Okay, velocity is scalar or vector quantity. So here scalar quantity means the quantity which is having only magnitude, and vector quantity means the quantity which is having magnitude as well as direction. Okay, now here velocity that is having magnitude as well as direction. So therefore velocity is a vector quantity. Okay, it is vector quantity. Next, based on that, we will solve the problems. Example 4. Example 4. Just page number 103. In that example 8.4. Okay. Example 8.4, page number 103. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. So here two situations are given, and velocity as well as time is given, and we have to find out the acceleration. Okay, we have to find out the acceleration. So now, as I told you in the previous class, if the velocity is given in a question, initial velocity is the velocity which is given in the beginning, and second given velocity is called as the final velocity. Okay, first given velocity is initial velocity, and the second given velocity is final velocity. Based on that, we have to solve the problem. So that is the easiest step to consider, or to find the initial and final velocity. Okay, here also starting from a stationary position. Okay, starting from a stationary position means the object is starting from rest. Okay, the object is starting from rest. Then, starting from stationary position, Rahul pedals his bicycle in a velocity of 6 meter per second. Attain a velocity of 6 meter per. So initially it is rest, means rest is given, that means u value is 0. U means u is the symbol used to represent the initial velocity, that is 0. Next, it attains a velocity, that means v is given, that is 6 meter per second in time 30 seconds. T is 30 seconds. Okay, then he applies brakes. So that means when he reaches a velocity of 6 meter per second, he applies brakes. Okay, he applies brakes. Then what happens? When he applies brakes, the bicycle comes down to 4 meter per second. Okay, that means initial velocity in this case is 6 meter per second, and final velocity becomes 4 meter, and time taken is 5 seconds. Now I will solve the problem. First I will write the given data. in case 1. In case 1, initial velocity initial velocity here, the object starting from rest. So that means initial velocity, and the symbol used to represent initial velocity is small letter u, and that is equals to how much? 0. Rahul pedals his bicycle to attain a velocity of 6 meter per second. Therefore, final velocity comma v is equals to how much? 6 meter per second. So in your textbook they give m s raised to 1, so that is wrong. M bar s raised to 1, or m bar s, or m s raised to -1. That is the correct method to represent the SI unit of velocity. And next, time is given. Time taken comma small letter t, that is equals to 30 second. Okay, small s is the symbol used to represent the second. SI unit of time is second. Now we have to find out the acceleration. Okay, see here, velocity is, initial velocity is 0, final velocity is in meter per second, that meter per second is the SI unit, then time is in second, and second is the SI unit. So now we have to find out acceleration. In the previous class, in the motion lesson, we learned the different expressions of motion. In that we learned one, that is v is equals to u plus at. Okay, this is one expression which is used in motion, and when we rearrange this, it becomes acceleration comma small letter a, that is equals to v minus u divided by t. That means acceleration is equals to final velocity, that is v, minus initial velocity, that is u, divided by time taken, that is t. Okay, so therefore now the values, we have to substitute the values. Final velocity is how much? 6 meter per second. Initial velocity is 0, time taken is 30 second. So it becomes 6 minus 0, that is 6, divided by 30. Now cancel the terms and comment me the answer. What is the acceleration? So 6 divided by 30 is present. Just cancel the term and comment me the answer. Fast. Here a is equals to v minus u divided by t. So when substitute the values, it becomes a is equals to 6 minus 10 divided by 30, because final velocity is 6 meter per second, initial velocity is 0 because the object is starting from rest, then time taken is 30 seconds. And now it becomes 6 divided by 30, 6 ones are 6, 5s are 30, it becomes 1 divided by 5, and 1 divided by 5 means it is 0.2, and unit is meter per second square. Unit is meter per second square. Okay, this is the case 1. Now we have to solve the second case. Okay, just look at the answer once again. So initial velocity u is 0, final velocity v is 6 meter per second, then time taken is 30 second, and we have the expression for acceleration, that is a is equals to v minus u divided by t. When substitute the values, it becomes 1 divided by 5, and 1 divided by 5 means it is 0.2 meter per second square. So here we have to write meter per second square because it is the SI unit of acceleration. So therefore acceleration in the first case is 0.2 meter per second square. Okay, or you can write 1 divided by 5 meter per second square. This is simplified form of 1 divided by 5. The next one, case 2. Okay, now you have to solve the second case. In case 2, keep your textbook in front of you and solve along with me in case 2. So what happens in case 2? Then he applies, he means that boy Rahul applies brakes. So he applies brakes and such that the velocity of the bicycle comes down to 4 meter per second square. So when he applies brake, that means before brake the velocity is 6 meter per second square. So that means when he applies brakes, that means in that position the velocity is 6 meter per second, and he applies brakes, and after 5 seconds the velocity comes down to 4 meter per second. So therefore in the second case, initial velocity comma u is equals to 6 meter per second. Okay, initial velocity that is equals to 6 meter per second, and final velocity is how much? Comment the answer. Final velocity in the second case is how much? Comma v is equals to dash meter per second. Comment your answers fast. In the second case, the final velocity is how much? Refer your textbook and comment me the answer. As Nagaraj and Sharada gave 4 as the answer. Sharada, you have to write the SI unit also, otherwise your answer is wrong. Devraju 4 meter per second. Okay, so that is 4 meter per second. So both initial and final velocity is in terms of meter per second. Both are in the same unit. Next, time is given, that is 5 seconds. Time taken, comma t is equals to how much? 5 seconds. Now all the 3 units are in SI. So now we have to find the acceleration. So again we have to use the same expression which we use in the case 1, that is acceleration is equals to v minus u divided by t, that is final velocity minus initial velocity whole divided by time taken. So therefore acceleration comma a is equals to v minus u divided by t, v minus u divided by t. So therefore a becomes v value so much 4 minus u value 6 divided by time is 5 seconds, and here 4 minus 6 how much? Minus 2 divided by 5, minus 2 divided by 5. So now minus 2 divided by 5 is how much? Comment your answer first. Minus 2 divided by 5, or you can write acceleration is equals to minus 2 divided by 5 meter per second square, or this is equals to minus 0.4 meter per second square, because here acceleration is decreasing, it is called as deceleration. Okay, acceleration is decreasing in this case, therefore it is called as deceleration, minus 4. Okay, this is about the second case, and this gives the complete answers of example 8.4. How many of you understood this? Just comment your name and click on the like button. Fast. Comment your names fast. How many of you understood? Fast. Next, I'll move to the next example. Before going to next examples, we have three equations of motions. Okay, I'll write that equations here. Equations of motion. Equations of motion. So totally we have three equations. The first one, V is equals to U plus 8. V is equals to U plus 8. Or another form of this is A is equals to V minus U divided by T. Okay, another form of the first expression. Because when we take this U to the other side, it becomes minus U, that is V minus U, and T is multiplied to A. When you took this T on the other side, it becomes division. So therefore acceleration expression becomes A is equals to V minus U divided by T. That is, acceleration is equals to final velocity minus initial velocity divided by time taken. Then second expression, the first expression is used to find out the final velocity. Now second expression, that is used to find out the distance. S here is not speed, S means here distance travelled by the object. Okay, so that S is equals to ut plus half at square. S is equals to ut plus half at square. Then third expression, V square minus U square is equals to 2as. V square minus U square is equals to 2as. In these three expressions, V is known as final velocity, U is known as initial velocity, A is acceleration, and T is the time taken. And S is distance travelled by the object. S is distance travelled by the object. So these are the three equations of motion. First one is V is equals to U plus at, and another form of the first expression is A is equals to V minus U divided by T, and the second one is S is equals to ut plus half at square, and the third one is V square minus U square is equals to 2as. Based on the requirements which are given in the problem, we have to use this formula. Okay, if we want to find out the velocity, we can final velocity, we can use first one or third one. If you want to find out distance, we can use the third one or second one. If you want to find out acceleration, and if all other data are given, then we can use first one directly. Otherwise, if distance is given, then we have to use this one or this one. Okay, so this is about equations of motion. Now based on that, we will solve the problem. So that is example 5. Okay, example 5. Example 5. Just keep your textbook in front of you. Okay, in the textbook it is given that a train starting from rest attains a velocity of 72 km per hour. So initial given value is initial velocity, second given value is final velocity. Therefore here initial velocity, train starting from rest. So that means here initial velocity is how much? 0. Okay, the next one, attains a velocity of 72 km per hour in 5 minutes, assuming that the acceleration is uniform, and find the acceleration and the distance travelled by the train for attaining this velocity. So that means here initial, final velocities are given, time is given, and we have to find out acceleration and distance travelled by the object. Okay, so now I will solve the data. Before solving that, first I will write the given data. Okay, first one, initial velocity. initial velocity comma u. Initial velocity is how much here? It is given that train starting from rest. A train starting from rest, that means initial velocity is 0. The next, it attains a velocity of 72 km per hour. That means final velocity comma v is equals to 72 kilometer per hour. All small letters, k is small, m is small, h is small. And here the velocity is final velocity is in terms of kilometer per hour. So that is not the SI unit. So therefore we have to convert that kilometer per hour into meter per second. In the previous class I told you about how to convert the given value if that is in terms of kilometer per hour, then how to convert that into meter per second. As yesterday I explained, that is we have to multiply the given number with the help of 5 divided by 18. With the help of 5 divided by 18. So therefore v value becomes 72 into 5 divided by 18. Just comment with the answer. What is the value of final velocity? Just multiply and divide this term, that is 72 into 5 divided by 18, and comment me the answer first. Comment me the answer first. Initial velocity is given, that is train starting from rest, that's why I consider u as 0. And then final velocity, after 5 minutes it attains a velocity of 72 km per hour. So therefore final velocity is 72 km per hour, but 72 km per hour, that is not the SI unit. Therefore we have to convert that into SI unit, and SI unit of velocity is meter per second. That's why we have to multiply 72 with the help of 5 divided by 18. So 18 ones are 18, 4s are 72, 4 5s are 20 meter per second. Very simple calculation. Okay, 70 kilometer per hour, meter per second. The next one, time taken. Time taken comma t, that is equals to how much? It is given that it is 5 minutes. 5 minutes is the time taken. So but minute is not the SI unit. Again we have to convert that minute in terms of second. So now convert the 5 minutes and tell me it becomes dash second. 5 minutes equals to dash second. For 1 minute 60 second. For 5 minutes how much second? Comment me the answer fast. For 1 minute 5 seconds. For 1 minute 60 seconds. For 5 minutes how many seconds? 5 into 60. So it becomes 300 seconds. It becomes 300 seconds. As Tejashwini, then Rizwan, Nagraj gave the answer as Suraj, Jyoti, Jeevan, Nagappa gave the answer as 300 seconds. Yes, that is the correct answer. Now we have to find out the acceleration. Acceleration comma a equals to v minus u divided by t. V minus u divided by t. Now substitute the values and comment me the answer. So v value is how much here? Final velocity is 20 minus initial velocity is object starting from rest. That means a train starting from rest. Therefore initial velocity is 0 divided by time taken is 300 seconds. Time taken is 300 seconds. Just simplify that. Okay, it becomes 20 divided by 300. Don't cancel the terms here, because here in the numerator subtraction is process is there and the denominators contain single term, so, but don't cancel the terms here. Okay, just simplify that. After that cancel, 0 and 0 gets cancelled, then 2 ones are 2 15s are. It becomes 1 divided by 15 and it is acceleration, therefore it becomes meter per second square. Keep the values as it is. 1 divided by 15 and its value comes as 0.0666, so on. That means we can consider 0.067, but we need that value for the further calculation, because again we have to find out the distance traveled. Okay, therefore keep the value as 1 divided by 15 meter per second square. Sharda, your SI unit is wrong. You wrote meter per second raised to minus 2. That is the wrong answer. Either you have to write meter per second square or ms raised to minus 2. These are the only two options to write the SI unit of acceleration. If you wrote meter per also as well as in the numerator in the exponent value minus sign, then the SI unit is wrong. The next part we have to find out the distance traveled. So we have one expression, that is s is equals to ut plus half at square. Initial velocity is known, time is known, and 2as acceleration is known, but distance is unknown. We have to find out the distance. Okay, 80 square, and apart from that we can use v square minus u square is equals to 2as. We can use any one formula. Okay, therefore we know that v square minus u square is equals to 2as. Okay, v square minus u square is equals to 2as. So I'll continue the next step here itself. V square value minus u square, initial velocity is 0, 0 square equals to 2as. So therefore v square equals to 2as. Here we know the value of final velocity, that is 20 meter per second. Don't use 72, because already we converted it into in terms of meter per second. So use the SI unit value only. Then this expression becomes s is equals to v square divided by 2a. V square divided by 2a. Okay, now we have to substitute v square value. V value is 20 square divided by 2 into a value. Just now we found the value of acceleration as 1 divided by 15. So therefore it becomes 20 square is 400. 20 into 20, 2 2s are 4, then 2 zeros, divided by 2, 1 divided by 15, it becomes 15 divided by 1. Okay, now comment me the answer first. What is the value of this distance? First, 2 ones are 2 2s are 4, 2 zeros, 15 into 200. 15 into 200 becomes dash. 15 into 200 becomes dash. So you have 15 into 2, it becomes 30, then 20 meter, that is s equals to 3000 meter, or s is equals to 3 kilometer, because for 1 kilometer is equals to 3000, 1 kilometer equals to 1000 meter, so that's why 3 kilometer is equals to 3000 meter, or 3000 meter is equals to 3 kilometer. Okay, just look at the answer. How many of you understood this? Just click on the like button and comment your name. First, now I'll move to the next one, that is example 8.6. Example 8.6. Example 6. In example 6, it is given that a car accelerates uniformly. A car accelerates uniformly from 18 km per hour to 36 km per hour. From 18 km per hour to 36 km per hour. That means initial velocity is how much? 18 km per hour. And the final velocity is 36 km per hour. And time is given, that is 5 seconds, in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. Again, here initial and final velocity is given and time is given. We have to find out acceleration and the distance traveled. See here, the initial velocity and the final velocity is in terms of kilometer per hour. So that's why first step we have to convert the value, given value, that is kilometer per hour into meter per second. That means we have to multiply the given term with the help of 5 divided by 80. Okay, first I will write the given data. A car accelerates uniformly from 18 km per hour to 36 km per hour. So therefore initial velocity comma u is equals to how much? 18 km per hour. So therefore u value becomes 18. To convert kilometer per hour into meter per second, we have to multiply with the help of 5 divided by 18. So 18 ones are 18 ones are, remaining is 5 meter per second. 5 meter per second. So in your textbook the bar is not given, so use the bar. Okay, meter per second. The next one, final velocity. Final velocity comma v, that is given as 36 kilometer per hour. 36 kilometer per hour. Again we have to convert that in terms of meter per second. Okay, therefore v value becomes 36 into 5 divided by 80. 18 ones are 18 twos are 36, 5 twos are 10 meter per second. Okay, how many of you understood this conversion process? That is conversion from kilometer per hour to meter per second. How many of you understood this? That is, we have to multiply the given value with the help of 5 divided by 80. Okay, I think everyone understood this process. That is conversion from kilometer per hour to meter per second. The next, time is given. Time taken comma t is equals to 5 seconds. Time taken comma t is equals to 5 seconds. Now we have to find out the acceleration. Acceleration comma small letter a, that is a is the symbol used to represent the acceleration. A is equals to v minus u divided by t, that means final velocity minus initial velocity whole divided by time taken. Now we will substitute the values. Final velocity v is 10, initial velocity is 5 and time taken, that is 5 second. So for time taken is in terms of second, that's why no need to convert that. Okay, therefore a value becomes 10 minus 5, it is 5 divided by in the denominator 5. 5 ones are 5 ones are. Therefore answer is 1 meter per second square. 1 meter per second square. How many of you got the correct answer? You have to solve along with me. Okay, then only you will understand the problems very fast. So how many of you got the answer as a is equals to, that is acceleration as 1 meter per second square? Comment your name. Comment your name first. That is acceleration, that is final velocity minus initial velocity divided by time taken. By substituting the values, you got the answer as 1 meter per second square. Now we have to find out the distance traveled. We can use s is equals to ut plus half at square, or we can use b square minus u square is equals to 2as. We can use any method. In the previous method, initial velocity was 0, that's why I used b square minus u square is equals to 2as for the simplification. And in this we can consider anyone. I'll use distance traveled or distance comma s is equals to ut plus half at square. S equals to ut plus half at square. S equals to u value is how much? 5, and time t is how much? 5 second plus half into a value, acceleration is 1 meter per second square and time is again 5 square. So therefore s value becomes 5 5s are 25 plus half into 1 is half, 5 square is 25. Now comment me the answer. How much distance it traveled? That means the car traveled how much distance? Comment me the answer fast. So s is the symbol used to represent distance, okay, not speed. And generally we are using small letter d for the symbol of distance, but in equations of motions we are using small letter s to symbolize the distance. It is 25 plus 2 ones are 2 ones are 2, 2 twos are 4, remaining is 1. After putting decimal point it becomes 10, 2 fives are 10, it becomes 12.5, and totally it becomes how much? 37.5, and it is distance, therefore unit is meter. So answer is 37.5 meter. That means the car traveled a distance of 37.5 meter with an acceleration of 1 meter per second square. Just look at the steps. Okay. Then I will move to the next problem, that is example 8.7. Example 7. We just read the question with the help of a textbook. In this example, it is given that the brakes applied to a car. So brakes are applied, that means the acceleration in the negative direction. Applied to a car produce an acceleration of 6 meter per second square. Directly they give the acceleration without giving the velocity, they give the acceleration. It is 6 meter per second square. But here the velocity is the acceleration is not increasing. because brakes are applied. When brakes are applied, the velocity is in the negative path. That means velocity goes on decreases. When velocity is decreases, that means acceleration is decreases. That's why for the a value we have to use negative sign. So when brakes are applied, so in that case we are calling that acceleration as deceleration, decrease in the acceleration. Okay, acceleration means increase in the velocity and deceleration means decrease in the velocity. So here brakes are applied, so therefore we are calling this acceleration as deceleration. And then in the opposite direction to the motion, if the car takes 2 seconds to stop after the application of brakes, time taken is here 2 seconds, and car gets stops, that means final velocity is 0, because initially that car was moving. When the driver applies brakes, after 2 seconds the car comes to rest, that means final velocity is 0 here. Calculate the distance traveled during this time. We have to calculate the distance traveled. Okay. See here, I will write the given data as acceleration comma a is equals to minus 6 meter per second square. Here it is decreasing, that's why I used here negative sign, minus 6 meter per second square. Then time taken comma t is equals to how much? 2 seconds. Time taken is 2 seconds here, and then final velocity because after applying the brakes after 2 seconds the car comes to rest, therefore final velocity v becomes 0. Now we have to find out the distance traveled. Okay, to find out distance traveled we have the formulas. One is s is equals to ut plus half at square. Another one is v square minus u square is equals to 2as. And the formula is v square minus u square is equals to 2as. These are the two formulas we can use in this problem to find out the distance. But when you consider the first expression, s equals to ut plus half at square. S is unknown, initial velocity that is unknown, and time is given, acceleration is given. Single equation, two unknown quantities. So distance is unknown, initial velocity is unknown, therefore we can't use the first formula. Then we come to second one, that is v square minus u square equals to 2as. Final velocity is known, initial velocity is unknown, acceleration is known, and the distance is unknown. Again single equation, two unknown quantity. Which is that common term that is unknown here except distance, that is acceleration, that is initial velocity. So therefore before finding the distance traveled, first we will find out the initial velocity. Okay, so that is by using the first expression of the equations of motion. We know that, alright, we know that v is equals to u plus 8. V equals to u plus 8. V value is how much? 0 equals to u value is unknown plus a value is minus 6 and time is 2 seconds. So it becomes 0 equals to u. Minus and plus minus, 6 2s are 12. So when I take this 2 to the other side, it becomes plus 12, and it is velocity, therefore unit is meter per second. So therefore initial velocity is found now. That is initial velocity is 12 meter per second. So here the brakes are applied, therefore acceleration is taken as negative quantity here. Then time taken is given in terms of SI unit, that is 2 seconds, and then final velocity, because after applying the brake and the car takes 2 seconds to come to rest, therefore time taken is 2 seconds, and the final velocity, because after applying the brakes the car comes to rest. So that's why v value becomes 0. Then we have two expressions to find out distance travel, that is s equals to ut plus half at square, and the second one is v square is v square minus u square equals to 2as. But in these two equations, single equation and it contains two unknown quantity, therefore we can't able to solve. So that's why first we have to find out acceleration. By using the first expression of equations of motion, that is v equals to u plus at, we found that value of initial velocity, that is u equals to 12 meter per second. Now we can use that the formula. Okay, next one, distance travel or distance, comma s equals to ut plus half at square, ut plus half at square. S equals to u value is how much, 12, time is how much, 2 seconds, plus half into acceleration is minus 6 meter per second square into time taken is again 2 seconds and time t square. So S value becomes 12 to the 24. See here, you can't cancel 2 ones are 2 ones are, because this is in the form of square. Okay, but you can cancel 2 ones are 2 threes are. So that is, it contains negative sign, but it is not in terms of square. So therefore I will cancel 2 ones are 2, 3s are 6. Plus into minus, minus, this is 3 value into 2 square. 2 square means 2 into 2. 2 2s are 4. So therefore S value becomes 24 minus 3 4s are 12. Comment me the final answer. What is the distance traveled? I simplified everything. Only you have to subtract and comment me the answer. What is the distance traveled in this case? What is the distance traveled in this case? Initial velocity is 12 meter per second and acceleration is minus 6 meter per second square and time taken is 2 seconds and the final velocity is 0, and only the remaining last thing we have to find out is the distance traveled, and everything is in front of you. Just comment me what is the distance traveled. So your distance traveled, that is equals to 12. 24 minus 12, it is 12 meter. Okay, you have to write the exact unit also. So this completes all the problems. Now we have to see the graph. So in our textbook the different graphs are given. Just I will glance about the graphs, graphical representation of motion. So in page number 104 they give one graph, that is to represent distance time graph. Okay, distance time graph of an object moving with an uniform speed. So here distance is considered in terms of in the y-axis and time is in the x-axis. That is very very important. Distance we are considering in y-axis and time in x-axis, and the graphs comes a straight line passing through origin. This is the distance time graph of an object moving with uniform speed. Okay, the graph, in that graph the x-axis is time and y-axis represent the distance, and then the graph comes a straight line which is passing through origin. Then second graph, so in this graph distance time graph for a car moving with non-uniform speed. Okay, so in the question itself, it is in the first statement, distance time graph. So that means in the y-axis we have to consider distance, and in x-axis we have to consider time. That's why we are calling these graphs as distance time graph. So it contains, in one axis it contains distance, in another axis it contains time. So the distance time graph for a car moving with a non-uniform speed, it just comes like a half semi parabola. Okay, so parabola means same thing, we have to get this side also, then only, just like it is U shaped, so then we are calling that as parabola, but it is half, that's why we are calling that as semi parabola. So these are the two graphs which represent distance and time, so that's why we are calling that as distance time graph. Next comes velocity time. Velocity time graph for a uniform motion of a car. Uniform motion. So uniform motion means if an object covers equal distance in equal interval of time and velocity remains same. Okay, if velocity increases, for example, you are riding a bike, if you are increasing the velocity, then bike suddenly moves fast, and if you decrease the velocity, suddenly bikes will stop. But a velocity, uniform motion, so that means if the object must cover equal distance in equal interval of time, so that's why in that case velocity remains same. So that's why velocity here, y-axis represent velocity and x-axis represent the distance, and the velocity is uniform. That's why here one for example, here it is given as 40 kilometer per hour, so or you can consider meter per second. Okay, the graph is a straight line which is parallel to x-axis, this is velocity time graph. In velocity time graph, in x-axis we are using time, and in y-axis we are using velocity. Okay, so that's why it is called as velocity time graph. Okay, next one, that is velocity time graph for a car moving with uniform acceleration. Velocity time graph. Well, when we tell velocity time graph, in that case the y-axis represent velocity and x-axis represent time. And in this case, the velocity time graph, see here given the velocity time graph for a car moving with uniform acceleration. So in that case, we are getting a straight line passing through origin. So this is the method of finding slope. Okay, the straight line which is passing through origin. Okay, the next one, these are the two graphs which represents velocity time graph for an object in non-uniform acceleration motion. Non-uniform. Okay, so here non-uniform. So x-axis represent velocity, y-axis represent velocity, and x-axis represent time. So it is non-uniform. And here in the first case, the velocity goes on decreases as time increases, velocity goes on decreases. We can call this graph as decrease in the velocity graph or deceleration graph. Okay, this is about the graph, distance time graph and velocity time graph. And the last one point, that is uniform circular motion. So in uniform circular motion, if an object, so circular motion means if an object covers equal distance in equal interval of time. In uniform circular motion means if a stone is tied to a thread and from center it is moving, okay, that is given page number 111. So this diagram. So in this case, what happens? It covers equal distance in equal interval of time. So that is the secret. To find out the velocity in this case, we have the formula V is equals to 2r divided by t. V equals to 2r, that is 2 times of radius divided by time taken. Okay, velocity equals to 2 times of radius divided by total time taken. That is, distance traveled is 2 times of radius divided by time taken. Okay, thank you everyone. I'll continue the remaining in the next class.